All right, welcome back. So I realized there's quite a few videos. The first one was just a cheat sheet. I'm back on page 14, and we are going to be looking at some word problems. You are definitely going to be needing your calculator here. So again, you want a calculator that has exponent capabilities, so like this, right? Or it might be a button that says Y and then X as a little exponent. So I don't have one of those in front of me, unfortunately. But what we're going to do is we're going to go through. We got a couple word problems to do, and then I'm going to get you going on your practice. So again, I'm on page 14 in the note packet. So what we're going to have to do is figure out if it's linear or exponential for each situation, because then we're going to write our equation. And then we're going to use that equation to answer the question. And then we're going to make sure that we understand the difference between the growth factor and the rate. So that kind of happens, kind of a little pattern here. So in 2000, the population of Denver was 553,594, and it increases by about 1.2% per year. So again, as soon as you see a percent, and now that I'm saying that, I want you to grab your cheat sheet that we made. And now that I realize that, is that if you see a percent, okay, see where I wrote that? That automatically means it's exponential. So, we're going to write an equation that models it for years after 2000. So this is just a general equation that I could use any time that I want to. So since it's exponential, that means I'm going to be following this format. And I'm going to need the beginning amount, and I'm going to need to see how it grows. So the beginning amount is this. It is this 553,594. I'm going to leave the comma out of it. So G is not 1.2%. The percent helps you get G. So remember, G comes from when you take 1 and you either add that percentage as a decimal or you subtract. It just depends if it's increasing or decreasing. So what we're going to do is figure out what G is. So G is going to be, because the population is increasing, I will take 1 and I will add 1.2% as a decimal. So again, you can always take 1.2 divided by 100 or move that decimal 2 times to the left. But here it is as a decimal. So you can see those equivalent versions right next to each other. And if I add those two together, my final G is 1.012. This is what I want to use. So now I'm going to write the equation that models it. So it goes, to get any new population, that's what Y would be. I would take the beginning population that I know, and then in parentheses, I would put my G, and then my X is an exponent. So whenever it says write the equation that models, you will leave X and Y as X and Y, and you will insert B and G. So now what we want to do, according to your model, what's the current population? Well, the current population is based on the fact that it's the year 2021. And X from here on out is going to be our time. So let's go back to our cheat sheet. See this? And X is very often going to refer to your time. So you might want to make a little note of that. Like I said, we were going to add to this as we go. Some things I don't necessarily think about as I'm making the cheat sheet with you. So X will be time. So how many years has passed from 2000 to 2021? Our X, which is our time, will be 21. So now what I'm going to do, and I do expect you to do this, is show me what you were about to type in to your calculator. And I'll put 21 right there. This is not math we could ever do in our head. So I'm just going to type in my calculator, and the nice thing, and again, if you haven't put this on your phone because you don't have it, I would do this. The nice thing about this is I can just type it in exactly as I see it. So I've hit the parentheses button right here. It's above the 8 and the 9. And then I'll put 1.012. I will close the parentheses button. And then I need to hit the exponent button. So this is the exponent button. Now, this is a newer operating system. There is the older operating system. I actually do have that calculator. And just let me show you once what that difference would be, because some of you don't have the newer operating system on your calculator. So we're going to have to turn this line on so people can see it. So if I type this in, I'll do it the exact same way. 553,594, parentheses, 1.012, close my parentheses. There's my exponent button. But what you're going to notice is this doesn't raise it. And I would have put in 21 for my 21 years, where here it actually raises it. TI got smarter with how this should look. So it doesn't matter if I hit enter on this one or enter on this one, you're going to get the same answer. So we need to think about what answers make sense. This is a population, so I'm not going to have percentages of a people. So I'm just going to keep my number at this, right? And I'm going to write it down. So how many people will there be? This number said out loud is 711,184, and I always need to label my answers in context. Whoops, sorry you couldn't see that. All right, so now we want to identify the growth factor and the rate. Well, the rate, again, is this 1.2%, which we did turn into the decimal. But the growth factor came from the fact that I took 1 and I added that decimal, so my final growth factor was this amount. Big difference. All right, let's look at the next one. Your bank account currently has $1,000, and to save money, you deposit $15 each day. So you start with 1,000, then 15, 15, 15. So since this is adding 15, that means this is going to be a linear format. So I'm actually going to put an L for linear over here. So again, I'll be filling in the format of y equals mx plus b. And I always start with b. What was my beginning amount? That was 1,000. And then m is always, again, if we use our cheat sheet and we look at the m side, m is the amount that you add or subtract each time. So m is the 15, and it's going to stay positive because we're adding. So now I'm going to write the model, and all models are y equals, and it's, you could do the mx plus b, but I told you in class that I would probably be switching it. So I think about, to know my new amount, I would start with 1,000, and I would add $15 every day. And again, you can put the 15x plus 1,000. That's fine. But there's my model. That one's done. Now, how many days will it take until you have 1,500? So again, let's go back to our cheat sheet. Most likely, in this scenario, x, so, I didn't have an eraser. Ugh, I'm going to use white out here. X, just like in the other one, will most likely be referring to time, and then y is going to refer to your new amount. So I just grabbed my cheat sheet. Let's write these things down. All right? And then I'm going to flip this over. You pause it if you still need to write, and I'm going to write that as well here, that if x is your time, y is your new amount. Okay? All these things I think of after we've done the video. Okay, let's keep going. So, if my new amount is supposed to be this 1,500, that's going to go in place for y. And now we're back to what we did in our very first chapter. We need to solve for x. I'm going to draw my wall, and I'm going to get x alone. So the first thing I'm going to do is subtract 1,000 and subtract 1,000. You have a calculator. You're more than welcome to use it. The 15x is still here. And now to move the 15, since these are multiplied, I will divide. And I don't know what 500 divided by 15 is. And I'll just do that on my calculator. And it's 33.33. So x is 33.33. And I will put days. So it's going to take me, whoops, sorry you couldn't see that, a little bit more than 33 days to do this. So it'll actually probably be finally on the 34th day, but we can leave the decimal. That's fine. All right, let's go to the next page and wrap this page up. So number 9, you purchased the new iPhone for, yikes, that's a lot of money, and it depreciates. Depreciates means the value goes down at a rate of 7%. Boom, I see a percent guaranteed to be exponential. So we're going to be following this format. I'll just be writing it every time for you. And I need my beginning amount. So the beginning amount of the iPhone was $12.99. And then I'm going to need G. Again, remember, according to our cheat sheet, G is where I'll have to take that rate and turn it into a decimal. And since it's depreciating, I'll subtract it from 1. So this is a decimal. Again, you don't know. 7 divided by 100. Oops, that's too many zeros. 0.07. So G is going to come from 1. I subtract it because it's depreciating. And $1 take away 7 cents is 0.93. So this is my final G. And now I'm going to write the model. Y equals, to get my new amount, it'll be $12.99, and then in parentheses this 0.93 to the x power. And remember, this is your new amount and this is time. So now we're going to do f of 4, which if I were to write this, it would be f of x equals, whoa, forgot my parentheses. And so remember, if I drew that wall and x is in parentheses, x needs a hug. So x will be going over here on the right. Again, always write down what you are going to type into your calculator. That way, if you get the wrong answer, maybe it's just that you typed something wrong into here. Okay, so $12.99, parentheses, 0.93, close the parentheses, hit your exponent button, and put it to the 4th power. So remember, this amount should go down. And it did. Wow, that lost a lot of value. So this is my answer. And this is money. So money always goes 2 numbers behind the decimal. You can just leave it like that. That's called truncating, where you just truncate, you cut off everything else. Or you could take the 9, and technically it should round to a 2. So either of those amount of things would work. So we found f of 4. So here's the first answer. F of 4, that's the first thing it asked, is this. And then we're going to explain what it means in context. And again, x, I already told you, it will be time. This 4 is time. So in 4 years, the value of the phone is, where is it? $971.72. So I explained what the 4 means. I explained the 900 number, and it's all labeled. So identify the growth factor and the rate. So again, the rate was this was the 7% that we turned into a decimal. And we got the G because we took 1, I don't have to put that in parentheses, I don't even know why I did that, and subtract the decimal to get the 0.93. So that's the growth factor, and this is the rate at which it changed. All right, 2 more. The cost of a 20-ounce box of cereal went from $3 to $3.08 to $3.16. And this happened from 2015 to 16 to 17. So we're seeing our time go up by 1. So I want to see first, is it linear? So is it adding? So what do I add from $3 to get to $3.08? I add 8 cents. And if I add 8 cents to this, I do get this. So this is linear because they are adding 8 cents each time. So now we're going to write the model. Again, we're going to fit it in as y equals the mx plus b. So to get my new amount of cereal, I had a beginning price of $3. I told you I was going to be putting B first, plus it's increasing by 8 cents every year. There's my model. And again, X is time, Y is your new amount. So if the trend continues, how much would a box of cereal be today? Well, if this started in 2015 and we're in the year 2022, and you know what, now that I think about it, I think I did another one of these as the year 2021. Wait, what years? I don't even know what year it is. Okay, anyway, good job. It's 2021. I'm right. Okay. No, it's 2020. Jeez Louise. So, yeah, sorry about that. That's wrong. It's 2020. So, if it's 2015 and now it's 2020, that means the time, my X, will be 5 years. Wow, that is such a brain fart. All right, so now we're going to write the equation. So to get any new amount, to get my new amount of cereal, I start with the $3. I just cut off those zeros. I don't need it. Plus, I'll be adding 8 cents for the next 5 years, right? So X goes in for there. And then, again, just turn on your calculator, type this in. Your calculator will do all the work for you. So 3 plus 0.08, I'll put it in parentheses. That just means, sorry, you can't see that, times 5. So a box of cereal today would be $3.40. Make sure you put that dollar sign. All right, how long would it take for the price to double? So if it started at 3, then doubling, that means my new price, this Y, would be 6. So I'm going to put that in. And I'll have to solve for X. So I'm going to draw my wall, and I'm going to start to get X alone. So the first thing I'm going to do is subtract 3. Subtract 3. I don't have a lot of room. So I have 3 on the left side of the wall and 0.08x on the right side. To get rid of the 0.08, since it's multiplying, I'll divide. And I need to go to my calculator and type 3 divided by 0.08. And wow, that's how long it's going to take. Who would think it takes over 37.5 years for that to double? So 37.5 years. Okay? All right, moving on. Question 11. Lola's Purina Pro Plan dog food costs $38.99. So this is somebody's dog. It's Miss Roseline. She's another teacher in 2018. And now in 2018, it's this price. So we're going to do this twice. And you definitely will have a question like this on a quiz. So first, we're going to treat this as a linear. So what would I have to add to go from this number to this number? You're not great with addition, just subtract them and that will tell us. So $41.72, and I'm going to subtract $38.99, and I can see if it's linear, that's how much they added each time. So my M is $2.73. My beginning amount was the original price that I knew about, the $38.99, and now I'm going to write my equation. So we're going to write an equation that helps us figure out the cost of Lola's dog food after 2017, because it started in 2017. So to get a new price of dog food, it starts at $38.99, and then I'm adding $2.73 every year. So I just filled in MX plus B. Now if it was exponential, then I have to see what would I multiply by to get this, and I have no clue. So going back to my cheat sheet, if I can't figure out G, I can take the Y value and divide it by the previous Y value. And you got to think of these prices as the Y values. So I'll take this number and I'll just divide it by this. So to get G, I'm going to take $41.72 and divide it by the $38.99, right? And 41.72 divided by the 38.99, and that's my G. Now this is a really long decimal. We only need to do the 2 decimals. We should do 3 decimals, but we're just going to leave it like that. So I don't need the 0, but let's put the 0. All right, 1.070, and let's just kind of come up with the rule that we will not be rounding. We're just going to cover everything up. Again, not rounding is called truncating. So this is my G. We have established G. My beginning amount is still that $38.99, and now I'm going to write my equation. Y equals B. G is in parentheses to the X power. That's time. That's the new amount. So what's the difference in cost after 10 years? So if I use my linear equation, right, and I put 10 in, because X is always time, let's see what that cost would be. And again, always write down what you're going to type in to your calculator. And the parentheses 10 just means timesing by 10. So on my calculator, $38.99 plus 2.73, parentheses 10, so $66.29. Then if I do the exponential version of it, again, I'll put my time in for X to get my new amount. This is my equals, oh, here we go. So to get my new amount, $38.99, 1.070, and again, in 10 years, 10 will be the exponent. So I'm going to go back here, 38.99, oops, too many nines, parentheses, hit that exponent button, and now I'll put in 10. And now the price is $76. And again, we said for money, let's just cut it off, 69 cents. If you really like rounding, then make it 70 cents. So $76.69. So what's the difference in cost? It's about $10. Okay? And that's it. That is our last video for week 11. Now, don't shut off yet. Silver cohort. When I'm making this video, it's Friday after school. I just saw you, and there's a chance I'm not seeing you this week. I really have a feeling that that's what's going to be happening, unfortunately. So you will need to come back and check this folder out one more time, because you will have to do the work that the red cohort is going to do in class. Got it? Good. That's it. I will see you at some point. I don't know when. Bye.